Okay, so we're going to touch on several things today. A few of them were a couple things I wanted to get into last week that we didn't have time to do. One of the things we're going to use a lot in this class is Git and GitHub. We used it in server-side scripting, but we mostly did it just through the Visual Studio. We didn't really use it through the command line much or through the desktop client. So we're going to do both of those today. We're actually going to have two labs today. The first one is really simple, and that's just a simple lab on GitHub. So one of my main goals in this course is by the time the course is done, actually probably even long before the course is done, to get everybody really comfortable with using Git and using GitHub. Okay? Did anybody use GitHub or Git at all when you're on co-op? So some people did. Okay? So it's something that really everybody should know and feel. I want to increase your comfort level that if you go in anywhere and anybody asks you to use Git, that you feel you know how to do it and you're comfortable with it. Okay, so that's the first thing we're going to do. The second thing we're going to do is we're just going to talk a little bit in general at a very high level about cloud hosting. And we're going to follow that with Git because really when we go to deploy our Node applications, typically those are deployed to the cloud. Most hosting providers, traditional hosting providers, they won't run Node applications. And the way that Git ties in is basically our deployment steps. So instead of just going from our local file system and using an FTP client and transferring to the server, the way we typically deploy to the cloud is we first deploy our Node applications to source control, so a place like GitHub or Bitbucket or even Dropbox. And most cloud providers let us then link a Git repository directly to a live website. So every time we push up a new repository, they're automatically synced to our cloud hosting. So we'll talk a little bit about how that works. We probably won't get into setting up your cloud accounts, although I kind of asked you to do that on your own. We'll look at getting stuff up onto the cloud in a couple of weeks, but we'll kind of give you a picture of where we're going with that. So that'll be kind of the first part of class. And then the second thing I promised you was that we would spend the rest of the class just kind of doing a bit of a refresher with JavaScript. Okay? Who, probably not a lot of you, who got to actually use JavaScript when they were out on co-op? Okay, not many. So for many of you, it's been a good 4 or 5 months really since you've done anything with JavaScript, right? Now your advanced client-side scripting class, are you taking that this semester or was that before co-op? Before, so you have no other JavaScript this semester, is that right? Okay, so what we're gonna do is do a bit of a refresher with JavaScript. We're also going to look at a few of JavaScript constructs that you guys probably haven't used because they're not really used on the client side, but we will be using them in this class for doing server-side JavaScript, including that really funky callback notation we looked at last week when we wrote our non-blocking JavaScript. So we had this where we were passing in a function as a parameter. So we're going to kind of dive into that syntax a little bit more because we're going to be using that syntax regularly when we're building our Node apps. Okay, so we'll try out a few things with JavaScript, and then the last thing we're going to do is I'm going to give you a second lab. Some of you I'll try and give you time in class, but the lab won't be due until tomorrow night. Basically what we're going to do, there's a good tutorial from Code Academy where we build a rock, paper, scissors game using JavaScript. So the tutorial is to go ahead, build that rock, paper, scissors game and submit your JavaScript file. Basically, you'll put it on GitHub and you'll give me a link to the GitHub repository. Okay, so that's kind of an online tutorial. It's nice because you can try your code and the Code Academy site will actually give you feedback whether or not your code is right, and they do it in stages. So you go through and you kind of build the game out in pieces over 10 or 15 pages, and then at the end you should have one script file that does a complete rock, paper, scissors game. Okay? So the GitHub lab we'll do in class. I think we should have time to do it in class. It won't take very long, should be like a 5-minute lab. And then the rock, paper, scissors lab, again, if we don't have time to finish it in class, you have until tomorrow night to do it. Okay? And then next week we'll dive into actually using Node. So all of our JavaScript we're going to do today is really just plain old vanilla JavaScript. It's not specific to working on the server using Node. We'll deal with Node starting next week. Okay. So for those of you who used Git when you're on co-op, how did you use it? What did you do with it?
Well, one of the ways you can, it's like when you're working developer end on Squarespace, one of the ways you can upload is actually through GitHub instead of through FTP. So I was using
Okay, so you were using it as basically as a deployment, as a step in your deployment process.
Yeah.
Okay, Carlin, did you say you used it? You were using it?
I'm actually on the code right now.
Okay, and how does where you're working, how do they use it? Are you collaborating with other people, or is it source control, or?
We mostly use Dropbox for collaboration. That's where we upload our files, and someone backs up all the files onto Git, like all the previous versions.
Okay,
You know,
so they're,
in case something goes wrong.
okay. Vadim, you said you were using it as well?
Yeah, it was just for some basic collaboration within sort of complex, kind of like what we did in class with you.
Okay, so you're working with somebody else and sharing code. You've got
Yeah.
shared repositories.
And I could see what they put, right? So this way it's easier to track what they were actually doing.
Okay, and which tools, because there's many different ways to access GitHub. So for those of you who have been using it, how do you access it? Do you use a command line? Do you use the desktop client? Use the desktop client?
I didn't use GitHub, I used, sorry, what's the other one?
Bitbucket is a common one.
Bitbucket, sorry.
Basically the same as GitHub. You can create an account there for free. Brandon, how about you? How did you access it? What did you use?
It was just connect up to it on my terminal client.
Through the terminal, okay. Now there are some code editors that actually have GitHub built right in. So if you've installed Visual Studio Code, which is one of the editors, if you initialize a Git repository in the folder you're working with, you can actually make commits to GitHub right through Visual Studio Code. Or, I don't know, is anybody using the text editor, the HTML editor, atom.io? Does anybody have that one or seen it? So atom.io, I can open it up. So this is a relatively new platform independent open source editor. It looks a lot like Sublime, actually.
Didn't it come out with some hardware for that a couple of years ago?
I don't know.
There was a standalone PC that's for Atom, I believe.
I'm not sure, there could be. So it supports things like JavaScript, CSS, Node, and right down at the bottom we see it was created actually by GitHub. So again, Git is integrated right into this. So if you're working on a local project, you can actually connect it to GitHub right from within the editor. You don't need the terminal or the separate GitHub desktop client. So these are all options, all different ways we can get in there. So you may want to play around with this, or even through Visual Studio Code. And I think WebStorm, which I've been using, which I used last week for Node, I think it also supports Git integration. So they're building this in now. Git is being built into a lot more of our code editors. So basically, does everybody have the GitHub desktop client installed? If you don't, make sure that you do. The place that you grab it for whatever your operating system is just go to desktop.github.com. It should recognize what OS you're on. So if you don't have this little utility, you'll want to install it. It's free, it's not a big download, so you'll want to go ahead and get it. And when we open it up, it looks something like this. Brandon?
We're confident with the terminal client, can we use that?
Absolutely. I don't care what you use. What I would suggest is have both. We'll actually we'll look at both. I was helping somebody with this yesterday. I mean, there are some advantages to using this, but certainly if you're more comfortable using the command line or terminal, by all means use it. We'll play with both today. Okay, and then maybe even we'll open it up and we'll look at how it works in Visual Studio Code as well. So we'll give you lots of different ways you can do this. So make sure you install this client. So really all about version control, so that basically we don't overwrite our work, right? Or maybe we're making a new change and that change then breaks something else. Well, if we've saved and overwritten, then we need a way to go back, to be able to go back to a previous version and pull out a piece of code or reinstate a file. So that's one value of doing this. And the way Git works is basically every time we make a new version, we're creating a new, in effect, snapshot of our project and we're saving it locally, right? So on our local file system, we can always go back and pull up an earlier version. But we also have the ability, by connecting to GitHub, to also store a copy of all those versions online, right? So if our computer blows up or gets stolen, we've got all our source control, not just our current version of our code, but any previous versions that we have, right? So we've got the command line tool, we've got that interface, as well as it integrates into a whole bunch of code editors. So it's becoming a regular feature of code editing as Git's kind of become the standard. So it gives us version control. It also lets us keep a central repository, right? Now, most of you are working on the same machine each time, but one of the benefits, obviously, of keeping a copy of our code on GitHub is if you don't have your machine for some reason, it's being repaired, you're getting a new machine, you've got a copy stored on GitHub where you can always get it. So you should never lose your code, one of the big benefits. The last thing is really collaboration. So Vadim mentioned he was doing this, right? He's working with someone else, and they could share their code online into a central spot, and they could also see each other's changes. So this is one of the best reasons to use GitHub. So in Project Studio on your team projects, you're definitely going to want to create a shared repository for everybody on your team so that all your code lives there. It's not a question of, you know, Martin's got one piece of the code somewhere and Scott's got another piece, Levin's got another piece, and maybe they're working on the same files. Right? So then when somebody uploads, they're going to overwrite somebody else's changes. GitHub is designed to prevent all of this. Okay. So the client, as I said, a lot of you already have it. So you can get, there's both Windows and Mac versions of it. Everybody should have a GitHub account already from last semester. So by default, you get a free plan. You can sign up. If you say you're a student, one of the things that it gives you is 5 private repositories. Because by default, anything you put on GitHub is public. So if you have an account, the other thing, if you already have an account and you just set it up as a regular account, if you set up a second one, you can then link and create the second one as a student account. You can link them together. It will allow you to do that. So then you could put private repositories up. So let's go through and play around with this a little bit. So basically, the basic kind of unit we have is known as a repository or a repo, right? So that's just one project. So all our code for one application will be in a separate Git repo. So in class, what I'll do at the end of each week is any files we build in class, rather than me upload it in the Blackboard, I'll create a lesson 2, you know, COMP2106, lesson 2 repo, and I'll push all my code there. So if you need to see my source code, you can just go to GitHub and you can download it, or you can view it online. Okay. So basically anything in the project. Now we also have the ability to exclude certain files. Maybe there's certain files we don't want to push up to GitHub, either because we're still working on them or because they're just support libraries that come with our project. It could be thousands of files when we build Node applications. We're going to have hundreds of supporting files that are just part of the Node core. We don't necessarily need to bother uploading those. Does anybody know how do we exclude certain file types or certain files when we're creating a repository if we don't want to push everything? Yeah, that's what we've got, this git ignore function. So there's a little hidden text file called git ignore when we create a local repository, and it lets us specify either certain extensions or certain file names that shouldn't get included when we're saving copies of our repositories. So basically the place we always start, and we'll do this together now, is so log into your GitHub account if you're not already logged in. I know for a few of you this will seem really slow and basic. That's good. That means everybody's getting it. If you've used Git enough for this to be easy, great. That's where I want you to be. So go to GitHub. I should already be logged in because I'm always logged in. So you just need to hover over the plus, click on the plus, create a new repository. So I'm going to call this one COMP2106 demo. We can put in a description if we want to. We don't have to. So by default, your repository is going to be public. So anything you put in here will be public. The only way you can choose private is to upgrade your account, or if you're logged in as a student account, you'll have the option you won't get prompted to pay if your account's set as a student account. So I'm going to make it public.
Can we do this on the like the app that download right onto our computer, or we do this online?
You can, but it's always easier to create the repository here first.
On GitHub?
Create a blank repository here first. It's simpler.
So we should be doing this right now?
Yep, so do it along with me. I'm going to leave this box unchecked. We'll deal with the README file later. What is this README file generally used for? Many times we look at code repositories on GitHub, we'll see a README file. What do you expect to see? What's usually in there? Matt?
Like just information explaining what the actual repository
Yeah, people use it basically as documentation. So if you're going to make a library of code available on GitHub as a public, as an open source module for anybody to use, the README file will be a description of how it works.
Can you scroll up the team? It's like with the names.
Well, you can really call it whatever you want. You don't have to match my name. So for example, let's just look at, just go here for a minute and I'll pull up a node package. Here, we're going to use this one later. So if we look at this package, we'll get into Express in a couple weeks. So we can see all the source code, and here's the README file. It's readme.md. So it's basically the documentation. How to use this code library is generally what that README file is for.
What's so special about the MD extension over TXT extension?
That is a great question, which I don't know the answer to. But we can find that. We'll find that out. So generally, this is used as a documentation file. So for now, we don't really need to worry about the README. We also notice what we've got here, if we want, I'll show you what's in here, I'm not going to pick, is we can specify certain types of files to ignore. So if these files are in our repository, these will be excluded when we do all of our syncing.
Where's Chef Cookbook?
I have no idea. Okay. So these are all kinds of files which we can ignore. We can also, if we want, choose a type of open source license. These are all different licensing models. I'm just going to leave these blank. I generally don't bother with these.
So that means you can use any license that
Yeah, they're all different types. So if you're making your code available on GitHub, basically when you're putting it on GitHub in a private repository, someone else can take it and use it. So these different licenses define the terms of how that code might be used. I couldn't tell you the difference between all the different types of licenses. So then I'll just click on Create. So now I have an empty blank repository. Now, one of the nice things, when we create the repository online in this manner and we make sure it's blank, when we don't include a README, it actually gives us all of the code that we'll need to execute in our command line or terminal in order to start putting files into the repository. So this is usually this is a typical workflow. Now, Scott, we could always try it later through the visual client. But most people will create them here first as blank.
It's a lot easier.
Okay. So now, let's go to our local file system. So I'm going to go into my node directory. And if you're on a Mac, go into the same directory you were working in last week. I think it's your user and your username. And I'm going to make a new folder here. We'll call it Lesson 2. Actually, you know what? I'll come back. I'll do lesson 2 for later. I'll make a different folder. I'll just call this Git demo. We'll put that folder there.
So keep the lesson 2?
Yeah, we'll use lesson 2 later. We'll make a folder called Git demo. So then I'll go into the folder. So we just have a blank folder. So all of the files that we're going to build here, we're going to want to eventually put in our COMP2106 demo repository. So the first thing we want to do, right now this folder is not connected to GitHub at all. and it's not connected to Git, right? I can put files here, but that's fine. We're just storing files on the system. It has nothing to do with Git. So in order to get GitHub to start watching for, in order to get Git to start watching for changes in our directory, if we look at the documentation, we're going to want to go into this directory in our command prompt and run the command git init. So initialize git here to start watching for changes. So I'm going to open my command prompt, or open your terminal, and I want to browse to my node git demo directory. So I'll run the command cd node. That'll take me inside of C users R Freeman node. And then in here, I'm going to change directories to my git demo. So now I'm in the same folder in both Windows as well as in my command prompt. If I run a directory command in command prompt or an ls command in the Mac terminal, shows me nothing, right? There's nothing, there's no files here. It's just a blank directory. So before we create files, we need to initialize Git. This will tell that Git installer that's running on our machine. It's basically a service that runs on your operating system, regardless whether it's Windows, Mac, or Linux. Once we initialize Git in that folder, Git will always be monitoring for any changes. So any new files we create, any files we delete, or any files we change, Git will be monitoring those changes automatically in the background.
So Git's always going to be hooked up to that file from now on.
To anything we do in this folder. So the way we run that, if we go to the instructions, is simply run this command, git init.
That's kind of funny.
So short for initialize. Okay. So now it says it's initialized an empty Git repository in this folder. So now I have two repositories, right? I've got one running here, and I have one in the cloud. They're not connected yet. We're going to add some files, and then we need to sync our local repository to our cloud repository. So I don't see anything here, right? But my repository is initialized. So now let's go here and let's make just a simple text file. So go back into your folder, make a new file. I'll just call it textfile1.txt. And I'll just open it up in any text editor. I'll just open it in Sublime for now. Doesn't really matter what you call this file. So I'm going to put in some text, doesn't matter what it says, and I'll save that file. So now we have to do a few things before we can get this file to sync up to our online repository, right? If I go back to my repository online and just look at it again here, right? It's still empty. There's no code here. There are no files in this repository yet. So the first thing we need to do is we now need to take a snapshot of what our folder looks like and store that in our local Git archive. So the first thing we need to do is we need to add any files to our local snapshot. So the command we're going to use is git add. Now there's a couple ways we can do this. In their example, they're using git add and they're adding just that one file specifically. So we can add one specific file or two specific files, or we can say add all the files in the project to our current snapshot version, which is what we want to do. So we'll type git add. So I could add, textfile1.txt. If I want to add everything, I don't know why this is a dot, not a star, but the dot means all the files in that folder. Okay. So we're going to add all of the files . We get no message, which is good. If there was nothing to add, we would have gotten an error. And then the next line on the left, it tells us we want to make a commit. This is an important word. What is commit? What does this do? This line of code here. So git commit. Anybody kind of explain? Anybody know what's going on here? That line I've highlighted in gray. What's happening there? Ori?
You said it's saving a snapshot of your work.
You got it. So it's a two-step process. First, we say which files we want to include. And then when we say commit, that means take a picture or a snapshot of what this folder looks like and include whatever files we've added. So you're right. So that takes a local snapshot. Okay, so that will save a new version in Git's archive on our local machine. We're still not connected to the GitHub website yet. What's that -m first commit? What does that part mean?
It's your first snapshot.
I could run the command, I'll give you a hint. If I run the command without this, it's not going to do the commit. It's going to fail. I can try it, but I don't think it's going to work. What message do you expect I'll get? Why is that -m? What does the M stand for?
Message.
Right, the M is the message. Why would we need to supply a message, or why would we want to supply a message each time we take a snapshot of our project?
Because we need to know that it actually sent through. Serve says that it sent through to this commit.
That's a really good guess. Not exactly.
So like each time we change the file, you know which one is the first one, which one is the second one. So
It could be. That would be true, although we'll also see when we look at the commits, we can see the date and time.
So when you look back, you know which changes were made, which commit or which commit you're looking for.
Right. It's basically a comment to ourselves. If over time we're committing multiple times, we want to put in a description of what that commit did. Right? We added the login form in this commit. So it's a description. Once we get a big archive with all kinds of commits, that message is a brief description. So if we look at another repository, let me go into another repository. So here's one, right? I have 9 commits here in this project. This is a little, so here are my commit messages. Every time I made a commit, I explained what got added or changed from the previous version. So this way, if we have to go back and find an older commit, we know which one to look at. Where did I add this or where did I change it? So it's basically a description, and this is where those messages show up when you look at the archive history. So one of the questions that people typically ask is, well, if I'm working on a project actively, I'm working on it all day for a week and I'm saving my work as I go, how often do I commit to GitHub? Like, do I commit a new snapshot every time I save a file? Or do I do it at the end of the day? Like, there's no right or wrong answer, but what do you think would make sense? When would it be a good idea? At what point, if you're actively working on something, how often would it make sense to make a new commit?
Milestones. So it's like if you got like the login form done, you push up the login form. If you're handing it off to someone else, you would push it up.
Okay, that would be one strategy. For sure, that would work.
Whenever the piece of code you're working on is actually functional and it's not necessarily bugged.
Okay, could be, yeah. So you push it once you've got something working. That would work. Kaylee, what do you think?
For me, I would do it every time I save.
You would do it on every save? So you would have like 200 commits a day if you were working all day? Okay, you could. Right? Any other thoughts? Mallory?
Just anytime I've had a version I don't know how to use.
Okay.
Even if it's not quite working yet, I want to try something else. Go back to the version.
Sure. So there's no right and there's no wrong. One of the popular suggestions is every time you make a major change in the application, make a new commit.
So, let me get this straight. Once we have this all set up, everything you do in this file, once you get hooked up to the cloud for GitHub, it will always be saved on GitHub. But if you want to just say, make a new version of it, like you type in a bunch of stuff and save it. If you want to make a new version of the file, you just save it again, but underneath a different name, sort of.
It's not underneath a different name. Every time you want a new version,
Yeah.
you make a new commit.
Yeah, that's what I meant. That's what I meant. The commit is different. sort of name. Like,
Right, but making a commit and pushing it, copying it to GitHub, those are two separate things. You can make commits locally on your own machine, which will create new versions on your computer. That doesn't automatically send those versions to GitHub. Sending them to GitHub is an additional step.
Okay.
So what you could do is you could make new commits as you're working to create new versions locally, and at the end of the day, then push the latest one to GitHub.
Okay.
Okay? So you don't automatically have to put every commit you make on GitHub. It doesn't go automatically. You decide. Okay. So we've made a commit. So we're going to commit our first snapshot. So we'll put in -m. In fact, I'll try it without, and I think I'm going to get an error. I think this is going to tell me you can't commit without a commit message. Yeah, please enter a commit message for your changes. Oh, and now I'm in this VIM.
It's friendly at least. Tells you what to do.
I forget what the command is to get out of this, so I'm just going to restart my command prompt. That's easier. There is a way out of that.
Semicolon Q exclamation point.
Yeah, I'll never remember that. I'm terrible with key code shortcuts, but thank you. Okay, so cd node, what are we in git demo? Okay, so I'm going to type git commit m, and usually for our very first commit in a project, the standard, it's kind of like the hello world, is usually to give it a message of first commit or initial commit. You can give any message you want. That's standard when we're starting and making a new. Okay, so it says one insertion. So it added that one text file into my commit. Okay. So again, we've committed it locally, so we now have a local copy of the archive. If I refresh my repository online, my code is still not here, right? I've made a snapshot on my local file system, so I could always locally go back and pull this version, but it's not in the cloud yet. So if somebody steals my laptop, they've got my laptop with all of my commits. I still have lost my code. Okay, so Scott, you see we've committed, but it's not online yet.
Yeah.
So that's what these two things do. Okay, so the next line of code, I think I can just drag this down a
Can you
bit.
copy and paste in this?
You can, but I would suggest for now, it's a good idea to actually type the commands because you're sort of committing them to memory much more so than when you copy and paste. So that git remote add, what does that do? Git remote add, and there's the URL to my repository.
That's going to add it to the cloud, correct?
Close.
It's pushing it remotely.
Okay, that's what this line will do. What about this one? So yes, Ori, that's the push command. So what's this remote add? What do you think that does?
Connecting it to the right repository.
Right. That remote add is connecting our local repository to our repository on GitHub. That's what links the two. It doesn't transfer the code, but it connects the two up. So we only have to do this at the beginning, the first time. Once we run this remote add, we only have to do it once. Then our local repository will always be connected to that repository online. So this line we only need to do once. So you can copy the URL from here. There's a little copy to clipboard button, so here's the URL, or you can get it from the address bar. The .git extension is optional. So now what I want to do is type git remote add origin, and to paste in the terminal or in command prompt, I can just right click and choose paste. Or I can put it up here. Make it bigger.
Push enter.
Yeah, and hit enter. If I get no errors, if it runs properly, there'll be no message. I wish there was a message saying, remote added successfully. That would be a good idea, but they don't give us that.
So if I was to say you typed in the address wrong, it would pop up an error, correct?
Yes. Now, I've also set my GitHub, my login is already saved in here. If you've just installed it, when we try to push to do, which was Ori said, that's where we're actually syncing our files to the cloud, it will prompt you for your GitHub credentials.
And it'll also give you a status on its upload
Right. Okay. I'm already logged in, so I don't need to do that. If you manually want to log in, the command is if you type git space config, I believe it will prompt you for your GitHub username and then your GitHub password. But if you're not logged in, the client will, the terminal will ask us for the credentials when we try to push. So now we're going to push. So we'll try git push u origin to the master branch. We won't really get into using branches. It's a bit more of an advanced topic. Does anybody know what so master refers to the branch of our code. We only have one branch, and by default it's always called master. What would be a scenario where we might want more than one branch of our code? There's a few different cases.
Branches is for, there are a couple of purposes. Like you can use branches to work with different people, but you can also, even working on your own, you can, when you're trying to work on some new stuff, like you already have like pretty good stuff like committed, and when you want to work on some new stuff but don't want to mess up the old code, you can create a new branch and work on that, and then merge back later on when everything is nice and
exactly. So branches would be the perfect example. Even if you're working for yourself, maybe you have a master branch, which is the one that's on the server. Then we want to create a staging branch. So we have a live application running. We don't want to touch that code, but we need to make updates or add changes. We can create a new branch called staging or development. We can do all our work there and push it to that branch, and then when it's all ready, we can merge them together. That's a bit of an advanced topic. We probably aren't going to do that. We're just going to deal with the master branch of our code.
I'm trying to type in like the username and work. When I try to type in password, is that letting me type out stuff in that field?
Well, you don't see it. It doesn't show you the characters. It still works. So I'm just going to push now.
But, okay, so I don't know.
So it says it's uploaded to this URL, to the master branch. So now if I refresh on GitHub, now we've got one commit. Here's my text file, and there's our commit message of first commit. And GitHub gives it kind of a hashed number. You can see the full commit. So GitHub will assign a unique ID to every commit. So now if I break my code and I want to go back, I can click on any commit to see the code from a previous snapshot or previous version.
I'm having a little.
It's asking for.
Is that letting me log in?
Yeah, so you're not logged in, so you have to put in your GitHub credentials. Enter your username and then enter your password in the terminal.
It didn't like my password.
Then try it again.
So
You may have just made a typing error.
I am logged in and it said that it failed to push.
Yeah.
Okay, is there any more of a description? Can you read exactly what it says?
Master setup.
Error failed to push some rest to and
And did you include dash, sorry, you included this, U, dash U, that stands for unconditional, push everything, origin and master?
Yeah.
All right, I'll have to come and take a look. Anybody else get that error?
Can't log in, but it's the right credentials.
Oh, okay.
I don't.
Okay, run the command git space config, and it should prompt you for your credentials there. Try them that way first, and then try pushing again, see what happens.
Mine went through. Yeah. It was typed in the password wrong. Too bad you can't really see the password though. Like I understand why, but it's kind of.
It's just a security thing.
What am I looking for here?
So type git space config. Does it not prompt you for a username and password?
It gives the large menu, it wants something else with it.
Okay, I have to check what the command would be. Hang on just a second. Let's check the command. Try it this way. I would do it this way. This should save it permanently. Matt, try git config -- global. So that should save it permanently. And then user.name, and then your GitHub username. If that runs, you shouldn't get prompted. Like, I don't get prompted anymore. My credentials are saved globally, so I can initialize GitHub anywhere, Git in any folder, and I no longer have to log in. My login is stored permanently.
My directory is actually not working.
It doesn't do anything. It just, when I press enter, it's just...
Have your other Git commands worked?
Like, the git config just gave me the list of options.
Even when you add this, git config user.name, sorry, do it this, even when you do it this way. So run the command this way. Like this. Git config -- global user.name, and then in quotes your GitHub username. What you're saying, Brian?
My directory is not actually working. Like, it's saying giving error volume in drive C has no label.
If it does not recognize the git command at all, then if you just do a search for git, you may need to download git itself. So if you just type in git and go to the official site, this is not GitHub. So it looks like git for some reason did not install properly on your machine. So you can get it from here. If you just go to downloads, you need the git library. So install it for your operating system, and then you may have to try running the commands again. This is only if you're getting messages in the command prompt or terminal saying it doesn't recognize any git commands. Once this is installed, that may fix it. That's the first thing to try. Is that working for you, Varun?
Installing right now.
It's installing right now, okay. So you don't need to do this if your git commands are running. So what we'll do, I think we'll take a break. I can help anybody who's still having an issue. When we come back, we're going to do one more thing with Git, which is we'll play around with the desktop client. So this is how we can push to GitHub through the terminal. What we'll do next is we'll add a new file to the file system. We'll add a second text file, and this time we'll try using the desktop client, and then we can also do it through Visual Studio Code. So you'll see 3 different ways we can commit and push our code to GitHub. And you can use whichever one you're comfortable with, okay? Then I'll give you a lab for you to practice doing it.